Okay, hi folks. I'm a little bit better now. I had to wake up. I did a little test fire video. Maybe I'll post it later, like test fire videos. But I'm like, uh, I got to put this stuff out though. It's this is how I protect my intellectual property. So let's see. Now, there we go. Right now, it's talking about this stuff here. So as I was analyzing the sun, it brought me to realize that the continents on the Earth were not migratory but precipitory. So this means that in the very same way that cold mass on the north pole of the sun, uh, basically spills over and falls down into the vortices, the very same thing happens with the continents on the Earth. So back in the day, let's say, for instance, the very earliest days of Earth's coalescence, the um, Earth's rotation may have been as fast as one day was equal to 8 hours. That may have been how fast the Earth would have to be rotating in order for um, the continental masses to have accumulated into Pangaea on the North Pole. And at the same time that Pangaea was formed on the North Pole, Antarctica was formed at the South Pole. Antarctica and Pangaea are not the same. In the very same way that the marshmallows in your coffee go to the top and the sugar and the chocolate, hot chocolate, fall to the bottom. Okay, so yeah, that's right. Antarctica is the sugar and hot chocolate of the planet for in terms of continental mass. Anyway, it's not the heaviest stuff, but it's heavier than your marshmallow continental masses that we live on. Okay, yeah. So here I was. I'm looking at the sun. This all has to do with trying to figure out our actual galactic angular momentum in relation to the theoretical AGC 203001 wormhole. And, you know, things happen and you get off on a tangent. And that's exactly what happened here. So I went back to reevaluate the reappearing coronal hole, photograph taken by the SDO. And the reason I did was because I began to realize that this coronal hole coming down here looks like Africa. And so I'm like, that's new. That's an exciting discovery. So what does that mean? That means that continents precipitated in the very same way you see this cold material precipitating from the North Pole of the sun down into the just below the equator here and fanning out at the bottom is very amazing. And it also confirms my DRCB theory of all DRCBs basically having the same kind of gyroscopic function. So just like the gas giants, you have and the vortical, 45-degree vortical type equatorial vortices, primary vortices. You also have the streams, whether they're lithostreams, plasma streams, as we now know, and jet streams, as we refer to Jupiter's stuff. All right, and that forms the stripes. And yes, the Earth has these stripes, and I will show in my illustrations how we know this. Okay, now, anyway, this stuff spilled down from the top of the North Pole up here, and you wonder, well, okay, this is interesting. So basically, this is cold material, and almost the entire North Pole of the sun in this particular photograph is bald. Bald and cold, right? And you're like, my gosh, why is it so cold there and you don't see quite as much coldness down here? Well, that's because you have the SMEGAWs, the supermassive electromagnetic gravity waves, pushing the solar system this way, and they're rotating and pushing the solar system right into a lot of friction and a lot of friction and confrontation with the bow wave, and it squishes the solar system into a disk, a lenticular shape, just like the galaxy is lenticular under the same pretenses. So it's doing all this stuff, and this bow wave is cold. It's pushing a lot of cold space onto our solar system, and the sun is the most exposed DRCB in our solar system because it's the largest DRCB. So it's called the bow wave chill factor, as I refer to it, and that's why we have a colder. Well, why isn't the North Pole colder than the South Pole on Earth? Because the sun is so much larger than the Earth. It's taking the brunt of that bow wave chill factor and protecting the North Pole of the Earth. So that means that the colder temperatures that are on our planet, that accumulate around our planet, are at the North Pole, and they fall. They go immediately fall to the South Pole at the bottom of the planet and accumulate down there, making the South Pole colder because the South Pole is in fact the bottom of the planet. Here's us flying through space. No, okay, it's this way. Here's us flying through space, North Pole. This is our galactic flight posture. North Pole, South Pole. Smegaz smacking the planet. Smegaz carrying that extra gravity, pull that material from the North Pole to the South Pole and make it kind of like the top to the bottom. Okay, that's why all of this material here is being pulled to the South Pole of the sun. Yeah. It has nothing to do with the sun's own gravitational force. The sun's gravitational force is strong enough to keep the plasma into relatively a shape of a ball, but it's not strong enough to deny the Smegaz their gravitational influence on the base of the sun. Down here is the base of the sun. All right, that's how that works. Okay, and so this goes into a lot of detail here. And as you can see, the red lines basically indicate the rotation of the vortex that we're looking at right here. And as this cold material came down, it cut off and blocked right here. You can just see how it just ripped right through here and blocked that flow of number 4 plasma stream. Okay, and bam, hit a brick wall. And then that made all this material that's flowing this way naturally come up into a pocket of no resistance, and it just started floating around because it was like, oh, I don't know where to go. All right, and then you have Santa's belt right here with its primary flow, and it's forced up, and it comes here, and it gets into the same blockage. Not quite as forceful as here, but the same blockage, and it kind of like sits around, and you can see how before the coronal hole busted through Santa's belt right here, there was a solid stream coming across over here and flowing down into what is now this prominence right here. And the prominences, as you can see, as usual, are located right on the vortical perimeters of our equatorial vortices. And basically, you're going to get these prominences most likely everywhere. Everywhere there's a tangent on a vortical perimeter, there is going to be a prominence. Or maybe something weird like this. I put a question mark there because I'm like, well, it's the exact opposite of a prominence. Everything else is prominent, and it's like this hole. I was like, well, that's strange. Okay, well, anyway. So the FT is your flowing tangent down here, and then you have your turbulent tangent at the top up here where all this stuff is falling right through here and coming down. And basically you're seeing North and Northwest Africa right here, and then it sweeps down into South Africa here, and then these little 3 tails of the Cerberus, or is there a 3-headed snake? We'll call it Cerberus right here. It's coming down into this stuff right here, and it really kind of looks like the subterranean ridges that come out from Africa, from your point of view, Africa like this, and they sweep across the ocean over toward South America, right? So I applied it to this, and this is what I came up with. Now we have North Pole orientation here, and the reason I canted my little tool that I have here, that's my little vortical marking tool, and I put it on here, and then I canted it so that I could raise South America, because if you have the curl of, and here's your subterranean ridges, if you have the curl of Africa going in this manner here, and it's well within the vortical perimeter, then you would expect that South America's, you know, southeastern tip and the Strait of Magellan would have been up in its well within its vortex, right? And so I decided I would raise it by tilting this particular tool negative 24 degrees to the left. And then I went and mapped all the other vortices, and when I did, nothing panned out. None of the vortical perimeters matched anything, least of all South America. And that's mostly because this vortex is cutting right through South America, right here. I'm like, what the heck? And so it didn't pan out for me. I told Nancy it didn't pan out. That theory just got shit canned. Okay, so we went back to the normal North Pole orientation and stuck with that, and then we lined up the northwestern corner of the this African Precipitory vortex, and it goes right up almost perfectly with the mid-Atlantic ridge right here as it crosses over here. And I noticed that it was just slightly above Spain, and more going through Europe, France up here. But it came down right through, well, imagine that, the Red Sea right down here. It cuts off the Horn of Africa and follows the eastern coast of Africa's southeast. And you're like, wow, this is incredible. This isn't just a coincidence here, ladies and gentlemen. This is something going on. And later on, though, I kind of dropped this guy down because you notice if you drop this guy down to approximately right here, and you have him a little farther west, and he's right on that margin with the mid-Atlantic ridge, and then it cuts right through, which explains why Spain has the appearance of being separated from France at this point. And then it cuts right through here, follows right through the center of Italy. Wow, that's why Vesuvius is there. And it goes right through here, and then it still cuts right through, the Red Sea over here. It's like that is some amazing stuff right there, right? And then I did this one over here, and I'm like, okay, and now I can see how the North Pole would have been rotating this way. The material comes down from the right side of my screen all the way down here and flows down into here. But for some reason, the Americas are just not filling in the holes quite right. And I'm like, what's going on with that? And I got down to the next one, and this one was like, oh my God, look, this is pretty close. But just like the African side, where you need to drop it down to where it actually does a better job of cutting through stuff, you'll notice that if we drop this one down and we line it up with that mark right there, and you can almost see this like arc coming through right through here, right? And then it comes out over here. And so I tried that, and I did that, and bam, wouldn't you know it, right there at the little point of the Horn of Africa, comes up, it does that little wiggity-doo, and or the Gulf of Oman or whatever, and it comes up over here, cuts right through China, just above the Himalaya. And because you can see the perimeter etched into the earth, that tells us that this vortex, or that the asthenospheric tsunami that created the Himalaya occurred before this vortex was active. And it comes over here, and then right over here you see the Philippines. So at the time that this vortex was active, the Philippines came into existence, most likely. So they're not as old as all the rest of this stuff. And then you'll notice that right here is the center of it, and then bam, here you have the Seychelles. The Seychelles vortex is, in fact, I'm quite sure, the oldest vortical evidence that we have on our planet to date that I can make sense out of, right? So these two vortices are not related at all. This is like the very first and oldest one that was basically etched into the planet. And then I decided That's what I need to focus on. I need to go back and focus on that guy right there. And when we're looking at Google Earth right here, you've got all kinds of things that have taken place that are not quite what we may have expected in terms of when they happened. And part of what I'm looking at is, this is what has begun to bring me to believe that most of all the horrible, really big events, traumatic events of our planet did in fact occur very early and not recently at all. We've pretty much been holding the same, basically for the most part, the same form for about 4.4 billion years. A little less than that, right? But who knows how long a little less is. And but what we can say is this vortex was not here when Seychelles was active. This vortex did not exist, and that means that there's something traumatic happened to the planet that caused this vortex to become active, and it rotates in the opposite direction. So we come back over here, look at that, and we're like, okay, that pretty much finishes out basically the phase 1 African precipitation. All right, and I'll go ahead and post this one.